Welcome to homework.
Okay, this problem is asking us to perform an aldol addition reaction in order to get a certain product. Okay, and as we can see, there are no other ketones or aldehydes that can undergo a reaction with this specific problem, so I'm just going to have to assume that each of these are going to undergo a aldol addition reaction with itself. Okay, and I'll describe that in very soon. Okay, so first up, I have to assume that each of these are going to be in basic condition, so let's just say it's in sodium hydroxide. That sodium hydroxide, being basic, is going to take off the most acidic hydrogen of this molecule, which in this case is my alpha hydrogen. Okay, so after that, I'll get the following product, in which I have my CH3, CH2, CH2, and I don't any longer have CH2, I now just have CH, and that's going to be connected to my carbon, oxygen, and hydrogen. Okay, so again, I have my lone pairs on that carbon, simply because I deprotonated that hydrogen, moving the electrons onto that carbon. Okay, and again, these electrons can go ahead and be delocalized by moving onto that carbonyl, but for this specific mechanism, we don't have to show that movement of electrons. Okay, so as I said before, this is going to undergo a reaction with itself. So I'm going to have another molecule of this aldehyde present in the solution, and that is going to go ahead and act as an electrophile to this nucleophile. So my nucleophile is in red. That specific carbon is going to donate its lone pairs onto this carbon. Okay, and again, we're donating them onto that carbon simply because this carbon is considered to be electrophilic. Okay, when I do that, I'm going to have to move the electrons up to this oxygen, otherwise this carbon will have exceeded its octet. So this is going to be my product. And I'm actually going to draw out the skeletal structure from now on, just because I have so many of these carbons. So I'm going to have 1, 2, 3, 4, 5 carbons total. So I'm going to have 1, 2, 3, 4, 5 carbons. On that fifth carbon, I'm going to have my my aldehyde. And then on that second carbon, I'm going to have the connection to this carbon. So this carbon right now corresponds to this carbon. Okay, and connected to that carbon, I have my oxygen, which has a negative charge because I moved the electrons up to the oxygen. And then I have the I have the 4 other carbons connected to that carbon as well. So these 4 other carbons are corresponding to these 4 carbons. So I have 1, 2, 3, 4 carbons. Okay, so that is my molecule so far. And now let's go ahead and move those electrons on this oxygen to get protonated, because I can't just have that oxygen with a negative charge by itself. So the next step in my aldol addition reaction is just to go ahead and protonate that oxygen, and I'm going to actually just use the water that was formed by the protonation of this sodium hydroxide. Okay, so I'm going to have a water in the solution, just like that, and that is going to go ahead and get protonated by my water. So my final product is going to be this, in which I have basically the same exact data as before, so I can actually just go ahead and duplicate this. Okay, and then my product is the protonated version, my product is the protonated version of that oxygen. So delete that negative charge and replace it with a hydrogen. Okay, so that is my aldol addition product, characterized by the presence of my carbonyl and my alcohol in that beta carbon position. Okay, so moving on to the next one. So again, this is going to undergo a reaction with itself, assuming that we're in basic conditions. So I'm in sodium hydroxide, and my sodium hydroxide, because this is a symmetrical ketone, it doesn't matter which one I take off, I just know that I'm going to take off the alpha hydrogen. So I can either take off one here, or I could take off one here. Okay, but again, it doesn't matter. Okay, so let's just go ahead and take off this one. It's going to result in the formation of this product. And again, I'm going to draw out the skeletal structure just because it's a little bit easier to draw out and faster. Okay, so I'm going to end up with lone pairs on that carbon, and now I'm going to undergo a reaction with another molecule of that ketone. So I'm going to have another molecule like this, and these electrons are going to go ahead and attack that carbon. Okay, and that's going to move the electrons up to the oxygen, otherwise this carbon will have exceeded its octet. Okay, so I'm going to form this product, or almost product, in which I have my ketone, and then attached to this carbon, which is corresponding to this carbon, I'm going to have the connection to my carbon. So this carbon right there corresponds to that carbon, and attached to that carbon, I have the connection to my oxygen, my 2 carbons on that side, and my 2 carbons on that side. Okay, and then the very last step is to protonate that oxygen with a negative charge. So I'm going to have my H2O in the solution, and I got that because I protonated my sodium hydroxide in one of the previous steps, and I'm going to end up with this as my product, in which I basically have the same exact data as before, the only difference being that I have the the O minus protonated. So instead of O minus, I'm going to have OH. Okay, so that will be my final product. Okay, and last but not least is this one. This is my cyclohexanone. So first up, I go ahead and deprotonate that alpha hydrogen. So we can just show that like this. already deprotonated, and I'm going to go ahead and attack another molecule of cyclohexanone. So just like this. Attack there, moving the electrons up to that oxygen. Okay, and my product will be this. Cyclohexanone. Okay, this carbon corresponds to this carbon. Okay, and that's attached to this carbon, which corresponds to that carbon. And attached to that carbon we have an oxygen and my 6-membered ring. Okay, and last but not least is the protonation of that oxygen just using water. So I can just go ahead and represent that right now. Okay, so that will be my final product. Okay, and these are all the products shown.